In this video, I am going to find the inverse of this given function f of x. And once I find the inverse, I'm going to show that this is in fact the inverse by finding the function composition. To find the inverse of a function, we kind of follow a standard process where we set the given function to y and solve for x. So we'll write y is equal to negative 7x cubed plus 4. And then we are going to solve for x in this one. So subtract 4 from both sides. That's going to give me negative 7x cubed on the right, and then divide both sides by 7, negative 7 I mean. Then on the left I'm going to get negative y minus 4 over 7, and on the right is going to be just x cubed because negative 7's cancel out. Or to solve for x, I take cube root of both sides. So I'll take the cube root of this and cube root of this. Why do I take cube root? Because cube root is going to cancel this cube. So that's going to give me x on the right, and on the left is going to be just cube root of this, which is going to be cube root of I'm just going to distribute this negative to the numerator, so that's going to give me 4 minus y over 7, just to avoid this negative sign. So now what I'm going to do, I'm going to switch the x's and y's. So that means this is going to be y and this is going to be x. So it's going to be y is equal to cube root of 4 minus x divided by 7. Now my claim is that this new function that I got is the inverse of this function, and I'll call it f inverse of x. F inverse of x, that's going to be cube root of 4 minus x over 7. So this is a function that I found, and I'm claiming that this is my inverse function of the given function. However, to show that this is in fact the inverse, I need to find the composition of these two functions, f composed with f inverse of x, and that should give me x, and also f inverse composed with f of x, that should also give me x. And regardless of the direction of the composition, I should always get x. So let's do the first one, f composed with f inverse of x. By definition of function composition, this is going to be f of f inverse of x, right? Now what I'm going to do, I'm just going to plug in my f inverse. I have the f inverse, which is right here. Is going to be cube root of 4 minus x divided by 7. Now I gotta think of this cube root thing and within the parenthesis as one entity, like the x, one unit, right? X going in there. That's an input. So what does this function f do to its input? It cubes it, multiplies it by 7, and adds 4 to it. Once again, what does f do to its input or value x? Is going to cube that value, multiply it by 7, negative 7, and then add 4 to it. It's going to do the exact same thing. Or another way of saying the same thing, every time you see x on the right hand side, you just put this cube root of 4 minus x divided by 7. So it's going to be negative 7 times cube root of 4 minus x divided by 7, this whole thing raised to the power 3, like x cubed, right? Then plus 4. Now note that cube and cube root are going to cancel. That's going to give you negative 7 times 4 minus x divided by 7, and then plus this 4. This negative 7 and 7 is going to cancel out. That's going to leave me negative 1 times 4 minus x. That's going to give me negative 4 plus x. I'm distributing this negative to 4 minus x. Okay, then plus 4. Positive 4, negative 4 cancel out. That gives me just x. So we just found out that f composed with f inverse of x is x. Now I've got to do the same thing, but the other way around is going to be f inverse composed with f of x, which by definition is f inverse of f of x. Now note my f of x is given, which is negative 7x cubed plus 4. Now what does f inverse do to its input? It subtracts it from 4 and divides it by 7 and takes the cube root. It's going to do the exact same thing here. So it's going to subtract it from 4 minus, so it's going to be negative 7x cubed plus 4, okay, and then divide the result by 7 and take the cube root. Now there is going to be some cancellations going on here. Pretty quickly you'll see. For this negative in front of the parenthesis is going to be like negative 1 times everything inside. So it's going to give you negative 1 times negative 7x cubed is positive 7x cubed. The negative 1 times positive 4 is negative 4. The whole thing divided by 7. That's going to give me cube root of negative 4, positive 4 cancel out. 7x cubed over 7. This 7 and this 7 cancel out. That gives me cube root of x cubed. Cube and cube root are going to cancel. That's going to give me x. So I just found that f inverse composed with f of x is actually x. So regardless of how I compose it, in both directions I get x, which is great. So the function I found is in fact the inverse of the given function. Now let me talk about a little bit the graph of this function. So basically how it's going to look like. This function is inverse of this function or vice versa. This function is inverse of that function. Now if you sketch them, it's gonna be mirror images of each other about the line y is equal to x. Now I'm not gonna sketch it. Maybe I'll try it, but it won't be perfect. This is how it kind of looks like. I'm not good at drawing, so this is, it kind of looks like this, one of them, okay, and the other one it basically looks like this. And I am way off here, so just bear with me. It kind of looks like this, and if you draw the line y is equal to x, this is y is equal to x, this is gonna be, so this is a mirror image of this, or this is a mirror image of that. This is a sketch. I'm not, as you can see, I'm not perfect on it. So the basic idea is that if two functions are inverses of each other, they are mirror images of each other about the line y is equal to x. So now let me summarize what I talked about here. We are given a function, we need to find the inverse of it. We set the given function to y and solve for x, which we did here, and then switch the variables x and y, and we get this, and we claim that this is my new function f inverse, which is the inverse of the given function. To show that, we need to find function composition f composed with f inverse of x, which should be x, and we did that, we got it. And then we have to find the f inverse composed with f of x. That means I should get x for this one too. I do get x. That means regardless of the direction of the composition or order of the composition, you should always get x. And then finally, these two functions are mirror images of each other or reflections of each other about the line y is equal to x. I hope that this discussion was helpful. Thank you very much.